Hey geometry team, and welcome to Unit 4, Day 4. We are going to be working on triangle inequalities today, seeing what happens when things don't match up and don't line up. So let's get straight into it. We're going to start off with the triangle inequality theorem. And this theorem says that the sum of the length of any two sides of a triangle has to be bigger than the third side. And let's think about that for a minute. I've got myself a trusty triangle here, okay? These two sides have to be longer than this third one. If this third one tries to be longer than the pink and the purple one, they don't reach to the end of it. They can't get there. And so these two have to be at least as long as that third side. It's always going to be shorter than the other two. If it's longer than the other two, they can't reach it. They don't stretch out far enough. Okay? And so we've got A and B together have to be bigger than C. A and C together have to be bigger than B. And B and C together have to be bigger than A. That's all that theorem tells us. But what that does is it lets us look at different numbers of triangles or different amounts of numbers and see, could I even build a triangle out of this? So let's see how that works. So up here, I've got three lengths. 8, 17, and 24. And I want to know, could I even construct a triangle that's that big? And so you think, okay, well, I've got 8 plus 17. Well, that's going to give me 25. Well, 25 is longer than 24, so those two are longer than 24. That works. That's what we want. Okay? And so I actually already had that in here. And then I tried these two. Now I'm going to try taking these two together. They together need to be bigger than this guy. So I've got the 17 plus the 24. Well, yeah, that's 41. That's a whole lot bigger than 8. And so definitely these two are bigger than that guy. Now I'm going to take my 24 and my 8 and see if together they're bigger. So 24 and 8 added up makes 32. That's definitely bigger than 17. And so the verdict is, if I have these three guys, then, well, yes, definitely, I could make a triangle. Now, this guy is a lot smaller than the other two, but that's okay. It doesn't matter if it's a lot smaller as long as it's not bigger. So then you come over here to this fellow, and we've got 41, 7, and 35. And you're like, I don't know, this is getting kind of fishy. Let's check and see how it adds up. Remember, each pair has to be bigger than the third one is by itself. And so we go, all right, if I take the 41 and the 7 together, that's going to give me 48. Just add them up. Well, that number is bigger than my other side. And so, okay, so far, so good. Then you think, okay, I'm going to try these two now. I tried the 7 and add it to 35. That gives me 42. It's close, but it is definitely bigger than this 41 side. And so I know that, okay, phew, it's still long enough to reach this third side. Then the last one, I take the two I haven't paired up yet. 35 plus 41 is 76. That's definitely longer than the 7. They can definitely reach to the ends of that. And so we know then that definitely, yes, this could be a triangle. See how this is starting to work? So now we try this one. We go, okay, 3, 3, and 7. I need to add up two sides to see if they're bigger than the third. So I start and I go 3 plus 3, and I only get 6. So these two pieces, a 3 and a 3, aren't big enough to reach the full length of that 7. So there's no way I could build a triangle out of this. It's just not going to be possible. And so my answer is, nope, that can't be a triangle no matter what. That's what that theorem, the triangle inequality theorem, tells us. And you're going to get to do some examples of that in the assignment coming up. Okay? Now, using that same idea, we can also figure out what's the shortest and the longest a third side of a triangle can be and still have it work. So, I'm coming back to this little guy I've made. And if you think about it, okay, this third stretchy side here, I can make it longer and longer and longer, but the longest I can make that third side of my triangle is going to be the length of this one side added to the length of this other side. It can't get any longer, or else the rubber band won't reach to the ends. And so to find out the longest my third side could be, I'm going to take the 3 and the 11, first two sides, and I'm going to add them to get the biggest possible length for my third side here. And so in this case, 3 plus 11 comes out to be 14. I can't remember if I had that filled in on here or not, so I'm going to write it on here. Now, how do I get the smallest this rubber band, what? That just went flying. The smallest it can be, I'm going to get it smaller and smaller and smaller. The smallest it could be is going to be the distance from this end to here. Well, that's the length I would get if I took the purple length and subtracted this pink length off the end. And this would be what's left. So to get the smallest amount this third side can be, I'm going to subtract the other two. And so I think, okay, on this guy, if I have a side of 3 and a side of 11, if I subtract those, the smallest my triangle third side could be is 8. And notice, I don't have equals on here. And the reason why is, if that third side did equal 14, it would be the same length of these other two, and that wouldn't be a triangle. It would be two equal length lines laying on top of each other. Okay? Then the opposite happens if I close it up and get the 8 here. Okay? Because I have my 3 and I have my 11. If this is only 8, it just reaches here and there's no length to open this angle up. It just becomes a line and two shorter segments together. And so do not put equals here. The only thing is the smallest it can be is anything just above 8 and anything below 14. Let's see if I made that clickable or not. Oh, yep, I did. Good. I made the 8, I made the 14, and they pop up. So now I can erase that and just save it to there. So now I go, okay, what about for 28 and 31? If I had two lengths, so maybe my purple and my pink here are 28 and 31, how long can this third side be? The shortest it can be, I will get by subtracting. The longest it can be, I will get by adding the two up. Did I do this one first or this one? I honestly can't remember. I'm going to go with this one. So I'm actually going to switch over to the 24 and the 7. So if I do this guy, the shortest it can be is I would do 24 minus 7 to get the smallest that rubber band side, the third side could be. And that's going to give me 17. The longest it can be is whatever 24 plus 7 would be. And that's going to give me 31 for that triangle. So that third side can be anywhere between these two numbers as long as it doesn't actually equal them. And yep, that's the one I did next. Phew, off the hot seat this time, Mrs. Cerna, you did it right. And now, so let's check this last guy. I've got two sides, one's 28, one's 31. It's going to have a really small range it can be. The smallest it can be will be whatever I get when I subtract 28 and 31. And I'm going to end up getting, I show the equation here, and I end up getting 3. And then over here, I would get the longer side by adding these two amounts. And so when I add them up, it gives me 59. And so the closer the numbers are here, I got a tiny little range here and a great big amount here from how it worked out. And so there's lots of things that triangle can be. Okay, so let's erase some of my junk and move forward. Now, ordering the sides of triangles now. So this one's fun because you think, okay, if you have a big angle in a triangle, see how that side can get longer and longer and longer. So a theorem in geometry is that the biggest angle is going to be opposite the longest side, and they always go in order. And so the longest angle goes with the longest side, the next biggest angle goes with the next biggest side, and the smallest angle always goes with the smallest side. So what that's going to look like here is if I have these three angles in a triangle, the smallest one here is 55, so the shortest side has to be A. Smallest angle, shortest side. Okay, so side A corresponded with the 55. You say, okay, well then the next smaller, so the middle one is the 60-degree angle, and so side B is going to be my medium length side. And then my largest angle here is 65, and so the 65-degree angle is going to be straight across, so the largest angle is going to be straight across from the longest side. That's how this is going to be set up. And that's just what that says over here. And so you go, okay, so knowing that then, you think, I'm going to look here, and I want to order these sides from smallest to largest. So I need to find my smallest angle first. So blah, 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 here's my smallest. And so the smallest side is going to be side C. Since I want to start with small, side C will be the smallest side. Then you go, okay, what's the next bigger one? You go, okay, I know how to add. And so the next bigger one is 60. And so the side across from 60 is going to be angle A. So that's the next biggest one. Our largest angle is 62.5. And so my longest side will be side B on there. Okay, let's see if I made that clickable or not. Nope, so I'm just going to leave it written there. Now on this one, it works in reverse. So you can go, okay, if I know what the sides are in order, I can at least know the order of these angles inside this triangle. So if I want to do the angles, smallest to largest, I'm going to need to look for the smallest side of the triangle. Here's my smallest side. So if you cut through and come to this angle, my smallest angle here is B. Making sure I'm doing it in the right order. I still did want smallest first. Then my next bigger side is 12. And so my next bigger, I pointed the wrong thing. The next bigger side is 12. So the next biggest angle cutting straight through is angle C. So angle C is next. Then my longest side is this 23. And so my longest angle will be angle A. And so we have these two different setups for triangles being unequal. They're either in ordering them or in figuring out how big the angles are. So I think that's it for this lesson. So go forth, figure out triangle sides, triangle angles, and we'll see you next time.